Welcome again to the next session of the Global Heat Flow Day 2026. My name is Sven Fuchs. I'm glad to give you an introduction into the Global Heat Flow database, into the status of 2026, and a bit also I would like to show how the things developed in the past years. On the example of the European dataset, but also on the general assessment we all did, or many of us did, in the Global Heat Flow Data Assessment Project. So, first of all, to those that are not familiar, I am talking about the Global Heat Flow Database because I'm also the elected custodian of the Global Heat Flow Database within the International Heat Flow Commission. The International Heat Flow Commission itself is a commission of and under the guidelines of the IASPI, so the International Association of Seismology and Physics of the Earth's Interior, and has also some co-sponsoring of the IAFSA and YAPSO, so volcanology and physics of the ocean science. So I'm a member of the International Heat Flow Commission, and I'm glad representing also the colleagues from the IHFC here and the numerous colleagues that contributed to the assessment. And while all this is rooted in the IUGG, we have also some support from the International Lithosphere program. So both programs from the IUGG and IUGS are, let's say, underlining and setting the structural framework of the IHFC at the moment. That are non-profit, non-governmental international organization. So when we talk about heat flow, I mean, it's clear what we are talking about for most of you. So I will not go into too much detail, but outline one important aspect that has been mentioned earlier as well. What do we actually record and what are we striving for? So what is the goal of the Global Heat Flow Database? And the goal here is clearly to document and to report and compile the heat flow data available. And since this wish came out of the, let's say, tectonic geodynamic interpretation community, we quite often strive to document terrestrial heat flow, which is an unperturbed surface heat flow. And unperturbed means unperturbed from shallow or deeper processes, or not deeper processes, but shallow processes or conditions that do not reflect the deep heat flow from Earth interior. What we usually measure is something very different. So we're measuring a lot of perturbations due to different processes and conditions we can see over here. And documenting both in parallel and showing this in parallel was not always an easy task, and is basically one of the reasons why we changed or why we did this kind of global assessment. At the very end, we have some fundamental questions to answer when we want to work with heat flow data. I mean, we have seen this earlier in the talk from Karim. Can we use heat flow, for example, for mineral exploration? More commonly, we use it, for example, for geothermal energy exploration, and the question is where to drill and how deep to drill, so what is subsurface temperature field. But beyond of that, Earth's evolution and the question of the Earth's interior and how, let's say, the primordial heat generation and domestic cooling relates, for example, to a measured terrestrial surface heat flow. That are questions of importance. No wonder heat flow played a role also in plate tectonic theory. And if we look a bit into, let's say, a deep Earth heat budget, as we can see here, then we can immediately see that a surface heat flow, whether it's 45, it's 50, 47, whatsoever, really is a crucial boundary we need for the understanding of the subsurface Earth interior. So the total heat loss we can calculate for the Earth's surface really depends on our measurements. So there's quite some motivation to get things done right. And as always, and we have seen this in the talk of the of our AU scope, data is quite often a problem, but we want to turn this into a solution. And the problem basically for heat flow data arises from the fact that we are collecting these data for more than 90 years. So within that time, science consistently changed. So methods, technology changed. The way how we document things changed, and I mean, from the early beginnings to the way how digitization and data science today, there had been several changes and jumps in technology on all levels, right? So we have a collection, or started with a collection that had been really heterogeneous. So with a lot of data and metadata we are missing today, with the understanding of today's science that has not been consistently reported in the past, because there were neither the awareness of its importance or sometimes nor the possibility or ability technologically development to measure it. So what we nowadays have are very heterogeneous descriptions. And since the global heat flow database went from hand to hand, there's also the question of data authentication. So when we started, for example, and here's just an example for Europe, how heterogeneous these data sets looked in the past, then this was really limited in several aspects. And the question of uncertainties, and if we want to use compilations for uncertainty quantification and models, really was difficult to solve. So all this in mind, in 2019 the International Heat Flow Commission developed a vision how to change things, and the simple vision is we want to have a quality controlled global heat flow database. And this is basically the process we went through in the past 5 years to achieve this goal, and we are going to achieve this in 2026. That we have a quality controlled data set that follows a unique and unified standard. And this required a lot of effort from many people across the globe, though in the meantime we have more than 150 volunteering scientists that contributed to these kind of efforts. So here on the map you see some of the locations where the people are coming from, contributing to a systematic assessment on a voluntary basis. The whole thing was supported by the task force of the International Lithosphere program for 5 years, and also by a fellowship program founded by the International Heat Flow Commission that enabled more than 23 people to travel across the world, learn about heat flow, but also contribute to the assessment of the heat flow, thanks to all these contributions. The whole assessment process started with standardization. Many of you know the Jessup et al. 1976 paper, so this was the baseline when we started a couple of years ago. This is quite remarkable. It was a remarkable paper, but even more it was impressive that after 50 years with all these changes in database technology, we still followed the same scheme. So this is something we changed in 2023, considering modern standards in data banking and so on, developing these kind of community standard, and we associated this with submission templates that helps you as a user to submit your heat flow data from your publication in a format to the International Heat Flow Commission that it can be directly implemented in the global heat flow database. When you use these kind of templates, you can also use, let's say, kind of quality codes we have published and we are working over at the moment that help you also to directly check whether your data are in compliance with the code requirement, with the quality requirements of the International Heat Flow Commission. So what exactly does this new system actually means, and what are the main parts here? So the main aspects are that we consider heat flow as a multi-dimensional parameter, and we implemented a kind of parent-child system. So that means that we, in contrast to earlier compilations, want to reflect and consider that at same locations we could have different determinations of heat flow or different status of corrections or of, let's say, methodological approaches. So we have a parent-child system implemented, while the parent metadata reflect information at the specific location, while the child elements reflect the different determinations and the metadata you need for heat flow conductivity, temperature, and so on. So we have seen the metadata talk from AU scope earlier. We are dealing with similar aspects here, how to, let's say, document those things in a transparent way that it is reproducible, and it can be, let's say, it is authenticated at that point. So the new standards from 2023 at the moment consider 62 database fields that help you or provide metadata that are helpful depending on your varying research needs. I mean, many of us coming from let's say fundamental geoscience, geodynamics, tectonics, maybe geothermal energy, but kind of heat flow data or shallow temperature data, thermal data are relevant in other fields as well, right? Glaciology, biology, and so on and so forth. So the different metadata fields should reflect the different needs you have, and provide also the ground for the basic quality scheme that users can make informed decisions based on their subject-specific requirements. The quality score we included or implemented here and introduced is threefold in nature. It means that it reflects three different dimensions, which is the numerical uncertainty quantification, the methodological reliability of a measurement, and of course local perturbation effects. So you can easily imagine that you could execute a technically perfect heat flow determination from a methodological standpoint, but you're doing this on the top of a volcano that just recently saw some glaciation effects. So what you're measuring may be technically perfect, but still have some heavy environmental impact and perturbation. So this kind of score tries to reflect this, and in this kind of individual scoring, we combine all those three simple scores into a U score, an M score, and a P flag. So the U score, M score, and the P flags, they reflect the different codes and variations here, and also, let's say, the kind of overruling effects in one comparable scoring. So with that you can compare the different child elements at a location or the different locations among each others. So that is the baseline for what we are doing or have been done in the Global Heat Flow Data Assessment project. So the HFC idea was to provide the new data collection, but also develop a data portal to make these data in a fair principle usable. So we have heard about this earlier, but also to foster, let's say, international collaborative approaches further. Our current state is that basically the entire global archive of heat flow data contains more than 4,500 publications. This is quite a lot. 2,400 of these have heat flow data inside. The others are supporting literature, modeling literature, and so on and so forth. But that are roughly the numbers of human mankind in terms of heat flow literature that is publicly available. What does it mean when we look at the global data? So that is the data status of end of 2025 as an example. You see the different years on the x-axis. On the left axis, you see the heat flow points that are published per year. So that are the bars. On the right side, you see the cumulative heat flow points over the year. That is the line chart. In red are the data from 2019. And in blue, the data from 2025, end of 2025. So we see that, let's say, as a result of the assessment, we have substantially extended the available heat flow data for each of these years. And this extension means we have more than doubled the data at that point, and this will be further increased in the next months. And we have almost tripled the literature considered. Also, these numbers will increase further. As it is in this kind of assessment, when you start to look into details and to read papers and publications, you find more. You find more references, more data that are not, let's say, publicly available or, let's say, on the screen of international heat flow community. So it's quite a learning process. Going through we also find a lot of double duplications, redundant data in mutable publications because these data has been republished. So this is really a challenge for the team that works on the data to discriminate between new data, republished data, corrected data, and so on and so forth. Quite something. But yeah, this shows really progress because we get more data, more information, and achieve a higher degree of completeness. So when we started in 2019, there was a famous publication of Lucas, who, let's say, after quite some time, provided a piece of work on a global heat flow database. He still based on the basic data scheme from 1976 with 18 metadata fields, and just barely the half of the data fields he was able to fill with information. Okay, so what we have done in the past is to extend the kinds of metadata field, but also to increase the degree of completion of these fields. With the release in 2024, it was barely half of the data fields filled from today, and our goal is really that we can provide information for each of the metadata fields, which means also the information that no information is available, so that these information are unspecified. That is the goal, and I think we are on a good way. When we look a bit on examples, and I would like to use here the example of Europe, because it's something we have really intensively worked on in the past month. The last compilation here is from the famous Geothermal Atlas of Europe, so from Hota et al. In 2002. They reported heat flow data from around 3,700 locations. So with our assessment, we will more than double this kind of work in terms of the data locations, and of course with the number of metadata fields where we provide information. However, an essential part is if you consider the number of measurements. So considering that you can have multiple heat flow determinations per location, then the number of data reported here increases from 3,700 to nearly 30,000. And this is really, really important because it brings us closer to the point to understand what kind of heat flow is actually reported. And this is important for different applications, that you know what kind of heat flow you use. So the new scheme provides a number of new dimensions for subsurface data evaluation. So we can start to map uncertainties, we can start to map methodological scorings, we can map the environmental impact and how the authors considered these kind of effects. And I mean, it's easy to imagine that all these things are the baseline if we want to come into, let's say, more specific corrections of data due to methodological artifacts or, let's say, in particular site perturbing effects. So we consider this as a pathway that we can reduce the risks from using these data, or at least make them transparent, and maybe also being able to quantify these kind of risks. In detail, it means right now for each of the data entries you have information about, for example, different metadata like the thermal conductivity, pressure, temperature conditions. Also saturation effects or the temperature methods, and you see that not in all cases these kind of information is documented in the publications at all. So we have quite some unspecified data sets, and it's also, let's say, a message from our side that we recognize that we need, let's say, come to a better training on how to report heat flow data. So what is important for the publications, and let's say this is something, let's say, we want to bring into the community, back into the community again, this kind of awareness. The nice thing here is when we look at this specific example here from Southern Europe, the research history for each of these location can be tracked through multi-site data. So what does it mean? Before and after the assessment, before we started the assessment, for example, a number of data or the most of the data do not have any uncertainty scoring. This is what we can change. We can add the data because they hadn't been implemented in the database, but we can also, let's say, add this kind of uncertainty scoring. Regarding Europe, we then come, let's say, we are in the process of doing this kind of mapping of the European surface heat flow in this kind. So for the entire of Europe, we find a continental mean heat flow of around 66 milliwatt per square meters for the kind of locations data records, with the given standard deviations here on the left side for the kriging itself. If we consider this, for example, only for the urban surface heat flow, so for the areas with population densities larger 500 persons per square kilometer, we see that the urban average heat flow is around 76. This is likely not because of the urban heat islands we have seen in the previous talks. It's simply because it's selection where the locations are, and probably that many of the urban areas are not in low conductive settings like the East European platform. So for this year, we are planning a detailed correction of the European data set and the full release, obviously, of the data and the grid. And let's say want to show a way how you can use these legacy data to come to kind of user-oriented metrics here. So there are 2 publications in preparation for the whole thing on the European side. But if we look a bit more into the global part now and the global heat flow database, what is the status and open assessment? We can look at the literature as a basis for information. So on the left side, it's just a small representation, 4,500 publications. This is what we have to deal with or to dealt with in the past. We screened almost more than 3,000 of these. So 1,700, the gray part here, that is completed and no heat flow data has been found here. So we found a lot of data where connectivities, gradients or supportive literature is available and could be theoretically used for future computations, but right now it has not been published as heat flow. The green part here, that are 1,900 publications where the heat flow assessment has been completed so far. The interesting part is the bluish one here in the center. So we have roughly 270 publications that already has been included in the release 2024, so where heat flow data are available, but that has not been assessed yet, so we are working actively on that. The challenge is a bit that around 110 of these references we do not have access to the original sources PDF, so this is a kind of limitations which will prevent us from really achieving 100% of assessment as long as we do not have these references available. For another 615 references, we have found these references during the assessment, so that was not expected before. Here again, around 133 references do not have PDF data. They are mostly from the US because the US is the last country we are working on right now. Our timeline is that for summer 2026 we expect the next and let's say final release of this global heat flow data assessment project. At the moment we are standing at around 76,000 locations with at the moment 143,000 heat flow determinations. We expect that this will further increase, so what you can expect in future is really a global heat flow database that has more data and more details and probably is really awaiting more detailed analysis in your region of interest. So all in all, it was quite some challenge over the past years, but I think the numbers are talking their own story. I consider really a scientific success. And it's also a collaborative success, because this was not done by single persons. This was really done by a lot of people, and I cannot name everyone here. Many here in the room has been participating in this process. So I just say thank you to the 150 scientists that really contributed to that effort, and of course also to my core team here at GFZ, which was doing a lot in coordinating those things and trying to get everyone on board. So what we now want to do next is that we come from the raw data to, let's say, a valuable data product. And this means basically that we need to come up with corrections. Corrections where we know that weaknesses are implemented in methods or in how the data are reported. This is something where we can come over, let's say, and we want, as an IHFC, come to the point where we use versioning of data methods and workflows. That it is really clear what has been used in terms of data methods and workflows, that this becomes reproducible as well. And finally, let's say, improves heat flow science and the derived interpretation in the very end. So we have worked basically on the left side here on the heat flow density data, so this is where we can add a check mark. But other aspects that are really interesting for the International Heat Flow Commission are obviously the question of rock thermal properties, high quality temperature data, and heat flow grids. So that are likely the next goals we strive for, where we want to, let's say, get an improved database or build these databases at all, and where we're really interested also to find your interest and to find you joining these kind of collaborations again. Another aspect, and this now targets less the fundamental geotectonic geodynamic questions and goes a bit more into oceanography. There is a working group in the International Heat Flow Commission on marine heat flow that really strives to establish heat flow as an essential ocean variable and to interconnect these science a bit closer to the global ocean observing system and oceanographers. So if this is something of interest, please also get in contact with Florian Neumann from Marum or Jeffrey Port from Paris, who are going to prepare and to promote these aspects. All in all, and finally, when the global update of heat flow data is finally available this year, it will be implemented into the heatflow.world platform, which is a host and home of the heat flow data of the International Heat Flow Commission, but it shall also be developed into something usable for the community. So if you don't know this yet, just check this out. It is in constant progress and development. So we want to make this, let's say, as easy as possible for people to learn about heat flow, to talk about heat flow, and also, let's say, to share results, literature, and so on and so forth. Finally, we are very grateful for a lot of financial support. Without this kind of financial support, it wouldn't have been possible also to make these kind of intensive coordination of a global collaboration possible. So that is just some support the International Heat Flow Commission or we as GFZ received for this kind of global heat flow assessment. And with that, I would say thank you very much, and I would be very much open for your question.